Thank you, Alberto. So, hello everyone. As Alberto said, my name is Ferran. I'm a Python developer, and today we're going to talk about Python packaging. So, if you ever wondered how can I make someone else install my code, for example, when I do pip install Django, for example, how can I make this package available for third parties? So this is what we're going to learn today. So first of all, my name is Ferran Jovell. I'm a Python developer. I'm currently looking for a job. So if anyone has any offers, I'm gladly to accept any at this point. I love Python, of course, and you can find me and more of my stuff at jovell.dev, which is my own website. So this is the index of the talk. So we're going to see what are Python packages, what is PyPI, where do these packages live, and then we will see how we can, like a bit of a recipe, or how can we create a Python package. Then I have prepared a bit of a demo. And then we'll have, of course, time for questions. And then I have prepared a few bonus slides in case we have some time later, kind of related to everything we're going to be talking today. OK, so first of all, we need to understand what is pip. So of course, we want to install packages, but in order to do this, we have this wonderful tool called pip, which allows us to install packages from the internet, or in particular, the Python packaging index. So I will talk a lot about pip. So if you didn't know, you now do. So it's the official Python package manager. So in Python, we talk about packages in a very broad way, in a very loose definition of the word. For example, in this example, my package is a Python package because it contains this dunder init file, and thus Python is able to import things from this package, from this folder even. And so we name this package, but also, for example, this is also named a package, something that we install from the internet. Like, for example, we often refer to the Django as the Django package, and so often they are mixed together and they are interchanged together. But technically speaking, we should be talking about these ones as distributions, because it's something that we distribute. It's something that we put somewhere else for someone else to download. Don't worry about this example. We'll talk about what this means later. But just have this definition of a package. And of course, packages, as I mentioned already many times, is something that we can install using pip. So pip is this tool that knows where to put the right files in the right places, so we can then import them in our scripts or in our applications. For example, if you do pip install Django, then pip knows where to go find these files, where to put these files once it has downloaded them, and then you can do import Python in your code. And of course, we refer as Django as a pip installable package because we can just pip to install them. And this is what we are going to learn how to do today. And just as a side note, every time you do pip install anything, I would recommend to use a virtual environment. If you don't know what it is, don't worry about it right now. But yeah, just something that you should always do. So what is the Python packaging index? The Python packaging index is where all the packages officially live. It's the official distribution, is where most, if not, well, I guess not all, but most of the packages live. And it's a community project, of course. It's funded, it's backed by the Python Foundation. And well, the URL, you have it there, is pypi.org. And when you upload a package, you upload it to PyPI, usually. Of course, you can have your private instances of PyPI. For example, if you have proprietary code from your company and you want it to be pip installable, but you don't want it to be publicly available, which is kind of usual, you would put them in a Python package, but your own. So let's go to the meat of the talk. How can we create a Python package? So first of all, of course, we need some code that we want to distribute. Basically, pip or the Python packages are to distribute code. So of course, we need some code. And then there are many ways to do this at this point in time, which is not very zen of Python, but what can we do? The newest way, or the most recent, or the most modern way of installing or creating packages is through using pyproject.toml, and you can find all the specifications in this PEP 621. PEP is the Python enhancement proposal, and you can find all the details there. And today we're going to see like the bare minimum stuff we need in order to create our package, but don't worry that you can find easily all the information in there. Of course, if you have been working on Python for a while, you will know about setup.py or setup.cfg. These are ways to install a package which are still being used today and are still working, of course. There is a proposal somewhere, I don't have the link here, to deprecate this, but I don't think there will be gone anytime soon. So if you use this, if you use setup.py or setup.cfg, don't worry about it. You don't need to migrate just yet. But if you have not, if you don't know how to create a package and you have to learn something, I would recommend to stick to pyproject.toml. Also, more and more projects that in the Python ecosystem are starting to use pyproject.toml for configurations. For example, classic example is, for example, Black, the formatter, uses pyproject.toml for configuration. So once we have this pyproject.toml file created and with all the right things in it, we will build what is called a wheel. A wheel is the file that appeared before, which is the actual file that will be uploaded to PyPI, which is, of course, the next step. And you upload this, and you're basically done. And once we have done this, and we have checked that the page for our package is created and everything seems to be fine, then we can use pip to install this package and download it from the internet. So we'll see really quickly pyproject.toml example. And this is more of what I already have said. You can use setup.py and setup.cfg. This is the old way. This is the new way through PEP 621. All the spec is defined there, and you can see very detailed examples as well, how to add all the metadata you need. Basically, this pyproject.toml is a file that tells the build tools where to find your code and how to name the things that are automatically named, the version, etc. We'll see. So there's a lot of things here. This is an example, of course, and this is basically the minimal example I could find for a PyProject file for you to be able to build your package. So first we have this project key, in which we will define a lot of metadata regarding our packages. For example, we have the name of the package. So for example, if we were to build this package and upload it, we would install it by using pip install my-demo-package. Then we have a version, which notice it's a string. It's not, you don't have to use any particular versioning conventions. You can use any, though, well, I have strong opinions about this, but we can talk about this later. And then, of course, we have some, oh, okay, sorry. And then we have some more metadata, for example, a description, a README, a license, and authors. I skipped one. This is just for PyPI to show what, to show the users what to expect from this package. And then we have, of course, requires Python. Requires Python tells you what's the minimum version that this package is allowed to run on. For example, in this case, the minimal version is 3.10. Of course, the oldest version that is not end of life is 3.7, I think, but it's going to be away soon. So yeah, I would recommend to pick the minimal version you want to support on your code and then put a bigger equals than, and you will be golden. Then we have a list called dependencies, which are the dependencies that your package, of course, needs. In this case, for example, it's Django. I love Django, by the way. I don't know if you noticed. And of course, this will be, when you install your package, pip will also pull all these dependencies along with it, and it will install at least this Django version that we put here. I will talk more about dependencies later on. So we will talk, yeah, we will talk about more why it's a minimal version and not, for example, a fixed version. And then we have some optional dependencies, which I will show you how to install them, but I use them in this case for installing the testing dependencies for my project. For example, in this case, I test my project using PyTest. So I put PyTest here, and it will download the latest version. And then finally, which is arguably maybe the most important part for the build part, is the build system. Setup tools is a library that allows you to build packages, and actually is the one that is recommended for in the official docs. Is an official package from the Python packaging authorization authority. And you can find this on the documentation, so don't worry about it. Like, you don't need to write it down. It's written down somewhere else in a website. So, with all of this, let's talk about dependencies. This is an important topic because, of course, if you have different objectives with your packages, you will define dependencies, and you will find the dependencies in a different way depending on what kind of code you have. For example, I have distinguished two ways or two main objectives for your code. For example, libraries and applications. So a library is a bunch of code that does something for you, but it's not intended as a final code by itself. So, for example, examples are Django, pandas, requests, in which you download and then you use these packages to create your own website or your own data science, whatever, or I don't know. And on the other hand, you have applications like, for example, my website or the black format that I talked before, or Airflow, if you know what it is, in which, well, this is something that you can take and run as is usually, and it's a final application. It's something that people will use. It's something that we'll use as is without any further code, let's say. So why this is important? Because, of course, as I mentioned, they fulfill different roles, and of course, they fulfill different roles, and of course, you will install them differently, and you will deploy them differently as well. So, for example, what's important for packages or libraries here are the metadata, for example, on what other packages they depend on, or what's the Python version that you are allowed for using this application. While applications themselves are usually installed through a requirements file, and they are meant to be final. And of course, as I said, we will pin dependencies in a different way. For example, for libraries, you don't want to fix a version of your dependencies because it can conflict with other dependencies. For example, if I have my website application, my API, for example, is written in Python, I will install Python, and then I might install, for example, Django REST framework, which depends on Python. And of course, if Django REST framework were to pin a specific version of Django, you would have a lot of troubles, for example, updating your application, or there might be some conflicts because some other third-party application needs another different version of Django, or an earlier version of Django, or what have you. While on the other hand, what you want in your application is to define exactly what version of Django you are using, because this code is to be used as is, and so you want it to be always the same to avoid surprises. Like, for example, if you don't pin your Django version and then install 4.1, and a few weeks ago the version 4.2 was released, and so, of course, between major releases, you can expect some breakages. And so you would have a problem here because suddenly your application stopped working and you do not know why, and it is because you haven't pinned your application, the dependency to a specific version. And this is very important, of course, because, for example, if I were to use a package that pins not only greater than equal or equal to, but exactly pins to 3.2, I would not be able to use my application because my application requires Python 4.1. And I think pip now kind of enforces this, but of course pip can say whatever. You can manage to install different versions or an incompatible version of your application within your set of dependencies, and it might seem to run well, but maybe at some point you find that there is something that is not correct, and of course you will have errors, and you will not know why. And the dependencies graph, let's say, it's usually the why. So now let's talk about how can we install our package dependencies. And of course, we can use pip. Pip is our main tool that will do almost everything for us. And in this case, we can use pip install in our directory of the package and use pip install dot or -e for editable dot, and it will pull our applications, our dependencies, sorry, into our environment. In this case, it will install, in the example before, Django. And it will install, I think, the latest version available because there's no upper bound on this package. So I also talked about optional dependencies, and in this case, you can use this syntax above with the square brackets and the name of the optional dependencies. And in this case, it will install, of course, our main dependencies and our test dependencies, which in this case is PyTest. And of course, you can use as many optional dependencies as you like. It's not test is not a specific or special name in here. It's just the one that I picked. And again, you can have as many as you want. For example, if you want to provide a specific version, for example, Django, and you want to, the example for Django, there is some libraries that do some hashing for the passwords, and of course, Django ships with one, specific one, and you can add optional better hashing for your application as an optional dependency. And I use this as well as a kind of development dependencies, even though, of course, any person that knows this optional dependency could install PyTest. But if it's not documented, you can then say, OK, this is not documented, this is not intended use, and you can save yourself from discussions, from I don't know, issues or whatever. So now we have everything ready to build our package. We have our metadata through pyproject.toml. We have our code. And then we want to build the actual package. So we use this tool called build. By the way, these slides will be available later, and there are links to everything that is not here directly. So you can find them later if you want to explore more. So again, if you go to the official Python documentation and on how to build a package, you will find that this is the way to build packages, and it's as easy as running this command here above, python-m, build, and then we pass the option will. Of course, you can build different kind of artifacts that you can upload to PyPI, but for our intents and purposes, we only care about wheels, and that's pretty much it. And of course, when you run your command, it will create this file. It's a WHL, a wheel file, and this is what we need to upload it to PyPI. So how do we upload to PyPI? Of course, again, we use this tool called Twine, which will literally upload whatever we want to PyPI. One thing that I would recommend if you want to play around with this, there is a testing instance of PyPI. As I mentioned, of course, you can deploy your own PyPI instance, and there's a test instance of PyPI, which is wonderful because it allows you to test these things. You can test your scripts, your automations, etc. So if you want to use the test PyPI, you can use this -- repository test PyPI option here, which I would recommend if you don't want to upload something that will be publicly available for whatever reason. But basically, all you need is Twine the upload, and then you point to the wheel file. And that's it. Of course, it will ask for your username and password. And if I recall correctly, this way of authentication against PyPI will be going away. And actually, if you use it, you will receive an email saying, hey, careful with this. This will be going away soon. But of course, if you are typing it manually, these commands, and you are testing things, I would say it's fine. However, my recommendation is to create an API token. You can create API tokens at the account level, and you can use this token as a kind of password, quote unquote. And it will do exactly the same, but PyPI will not complain about it. So, of course, having to type your password or your API key is a bit annoying. So my trick or my advice would be to put your credentials in a PyPI-RC file in your home folder. Of course, do not ever commit this file. This contains sensitive information, and whoever has this information would be able to upload things to your account in your behalf. And of course, I hope I don't have to tell you why this is a very, very bad idea. But of course, Twine will read this file and will take this information and will not prompt you for username and password. One thing that, if you try to create an API token for PyPI, you will see a page saying, hey, this is how you use your API token, and the only thing is here that the username is dunder token, and then you put your very long API key afterwards, and it should work fine. I tested it at home; it works on my machine, so don't come at me. So yeah. This is it for now. It's easier than it sounds, and when you have done it 1 or 2 times, it's super easy. Of course, you will find if this is the first time that you ever do this, of course you will find problems or whatever, but that's the beauty of it. So I have prepared a demo, and I will show you everything that I've talked up to this point in detail, in the real world, let's say. So in here I have a very cool, do you see the screen well? Yeah. Okay, awesome. So, okay, 1 second. Cool. Yeah. Okay. So, this is a code I want to distribute. Of course, it's a very simple and stupid code. For example, if you take a look at here, and here it's just a function that says hello, hello, and says hello, hello, Python Barcelona. So we can execute this code to check that it actually works. Wait, I don't remember the name of the scripts. Yeah, okay. -m example, whoops. And it's just a simple script that executes our function to check that, of course, our function or our library in this case works. So now, if we wanted to test this, I've written some tests because I like testing. So what can you do? So we can also run the test to check that everything is working as we intend. So in this case, we will run pip install pytest. Of course, it's already installed because I already checked that it was working, but we will install pytest. And we just can run pytest and see, okay, our test passed, great. So now that we know that our application works with a real example and our test passed, we are ready to build our application. So if you recall, first, what we need to do first is to install this tool called build. So pip install build. Okay, it's installed now. And we will run the command that I showed before. So it's just python -m build --wheel dot. Dot is to indicate that this is the directory we want to build, or if we wanted to build another directory, we would specify this in here. And of course, it will output some stuff, and it will create an isolated environment. It will download a version of setup tools, and it will, well, this is just all the information that it tells you. But in the end, what we have here is in our dist folder, this file that I think you may recall from earlier. And wheel files are just a compressed, I think it's a tar file that is so a zipped file that contains everything that you need. And pip will download this package and compress it or untar it and put the things in the right places. And that's basically it. Now that we have our package installed, actually, one cool thing we have, one cool thing that we can do is once we have this wheel file, we can actually install it. So we can do pip install this blah blah blah, and it will install it. So that's awesome. That's half of the job that of what pip does. And now we are ready to upload our package to PyPI. So we need to install Twine, which is of course installed. It pulls all of its dependencies, and we would do Twine upload this, and we will point to the wheel file. Of course, as you saw, here would ask for username and password. I don't want to upload this to the actual PyPI because there is no need for it. But trust me when I say that you can do this and put your username and password, and it will work. And we would go to pip, and then we would be able to install our package. And yeah, that's pretty much it. Yep, for the demo. So let's recap on what we did. So we have some Python code that we want to distribute, and we have tested it. We have written tests. We have checked that it works. So what you have to do is package it with the build tool, and then upload it to PyPI using Twine. And now, if everything is fine, if we didn't get any errors, we can just pip install our package, and we're done here. And yeah, that's great. That's all we wanted to do today. Of course, there's a bit more to it than this. This is a very simple example, but I think it is a very good way to introduce yourself to the packaging world, let's say. And of course, you can check the documentation for more details or other tricks and stuff you might need in your packages. So, for example, one thing that we haven't covered today, even though I talked about it, is running tests. So tests are very important for checking that your application or your package is working as you intend. And you can do some automation around that, for example, using a continuous integration, continuous delivery tool. For example, GitHub Actions or Circle CI or GitLab CI. And you can automate your deployments there and your testing, and only upload your package once the tests have passed or once all the linters have passed, etc. Of course, as you saw before, we required at least a minimum version of Python, which is 3.10. But of course, we have already 3.11, and 3.12, I think it's due in October. So of course, you want to check that your code works in all the possible Python versions that people can install it under. So this is another thing that I would encourage you to consider as well, because of course, for example, there is some syntax changes between Python 3.10 and Python 3.8, specifically when on the typing side of things. So this is a very good way to ensure that your users that are using an older version of Python do not suddenly find themselves not being able to run your code because you didn't consider something. And then, of course, I talked about versioning briefly before, and basically, if you do not know how to version packages, they are two main school of thoughts. One is Semver or semantic versioning, and another is Calver or calendar versioning. They are different, and if you can go check what each of them mean, but it's very simple. Semantic versioning, you have your three different numbers for your version, and each of them increasing or not mean something different. For example, if you increase your first number, it means it's a major version, and in which your users can expect breaking changes with previous version of your package. Of course, this is all defined on the Semver website, so don't worry too much about it right now. But on the other side, calendar version refers to when you release your package. So, for example, if we were to release this package today, under Calver, we would use, 04/23, for example, because it's the April version of the 23rd year. And of course, you can use any of this with Git tags, which I would strongly recommend you use Git tags to version both your Git history and your code at the same time, let's say. So then you can, if you have to roll back your code or whatever, it's easy to just do a Git operations to eliminate whatever bad code or revert or whatever. And yeah, that's it. Thank you everyone for your attention. Of course, you can find more information about Python packaging in the official docs, which is packaging.python.org. And as I mentioned before, you can find these slides available on the internet on my site, slides.jovell.dev. And you can click on all the links. It will take you to the appropriate links that I have put here, or documentation or whatever. And yeah, thank you. So now if you have any questions, please feel free to ask them. Yes. Yes.
Are packages that are uploaded ever scanned for malware?
That's a good question. I think that PyPI does some kind of checking, but I'm not sure that is exhaustive, because of course packages are very difficult to scan, or just like statically scan a package is very hard for scan for malware. And of course you can upload anything. And I'm sure it goes against the terms of service of the Python packaging index, but it's very hard to find malware just by checking the code or the package itself. For example, I know that there were some packages some months ago that contained that pulled all your environment variables and uploaded to some shady server. But this was not detected from PyPI. It was detected from the users that said, hey, this is something weird is going on, and then you can go check the code. Of course, you can download the package, and without executing it, you can unzip the package and check the content, because at the end of the day, Python is a dynamic language, so it's not compiled. You have to have the actual code in your environment, and they found that it were uploading sensitive information to a shady server. So I would say no, I don't think PyPI does anything. Of course, there are tools that allow you to check for vulnerabilities, and that at least you can ensure that the packages that you are uploading are safe. But of course, this is open source. Everything is open source. So in theory, you should check whatever code you are running yourself. Of course, checking every line of code is very difficult. So usually, what you can do is gauge at the engagement from the community. For example, the number of stars on GitHub, the last time this code was updated, or how many issues are open. But yeah, I don't think that PyPI does any malware check.
There is sort of golden track of most popular packages for which there are kind of registered maintainers. The new uploads have to be cryptographically signed. So at least for the most popular packages, there is a large amount of the most popular packages. Like not everybody can upload any requests.
Exactly.
So the malware normally comes in the so-called typo squatting. So they basically upload a package that has a name which is very similar to requests, has the same code, and then some malware, and then somebody will install it.
Yeah. Yes.
Are version numbers immutable? Like, can you change the contents of your package without changing the version number?
Strictly speaking, yes. So PyPI allows you to delete a version of your package, but if you do not delete this version, it will not allow you to push a package with the same name and the same version to their servers.
If you delete it, will allow?
Yeah. So as a repository owner, for example, I have the ability to delete certain versions of my packages. But of course, if you do not have this kind of access, you cannot delete any particular version. But if, yeah.
If a package becomes destructive, let's say, so pinning the version as a dependency may not be enough then, or is it enough?
Yeah, well, I think this goes beyond what you can control. Of course, you can pin your version and assure that at least your code will run as you intend because you have tested it with that particular version. Of course, you are always vulnerable to third-party attacks. Like, of course, someone leaked an API key and got access to, for example, the Django repository in PyPI and uploads a malicious version. Of course, this can happen. It's very unlikely, but you have always to be paying attention. Like in the cybersecurity supply chain side of things, you have always to be paying attention for these kind of things. So it's very hard for you to be 100% sure that the code you are downloading is good. Of course, there are certain safeties, as Alberto mentioned, like signed packages, and of course you can always check the package yourself. Of course, this is very hard, but what can you do, right? Yes.
You told us about this testing PyPI.
Yes. Yes.
I have a question. If you upload that package there, the dependencies that you put are from that test environment or from the real PyPI?
That's a very good question. I don't know. I would assume. I think that how pip works on the backside, if you do not specify anything, pip will always try to reach for the PyPI, the official PyPI instance. But if you specify a different index, it will try to search in that index first, and if it doesn't find anything, it will try to reach to read the official index.
If they have two packages that they want to test, but the dependencies go also with other standard packages, it will go into.
Yes, exactly. Yeah, I remember, for example, in one company I worked, we had our own PyPI instance, and of course we had our own library for web scraping in this case. But of course we used requests, and of course request is not a package that we own. And of course, we would download our library from this instance, and then request would be found in the official PyPI instance. Of course, test or instances of PyPI are also used not only for testing or for having your own code, but for example, if your company has to hit PyPI lots of time because, I don't know, you build a lot of Docker images or you install dependencies all day long for whatever reason. It's also a very good practice to have your own PyPI instance as kind of a cache for PyPI, so you can download it once from PyPI and save it to your instance. So every time you don't have to hit PyPI, because it's a project that is maintained by the community with funds from the Python Software Foundation. So it's good practice if you have the means to have your own and install it from there. But that's a side note. Yes?
I was going to ask that. How hard is it to set up your own private pipeline?
There are.
Years ago, it was really slow.
I actually don't know how hard it is, but I know there are actually already built applications that are not actually PyPI themselves, but are PyPI-like, so they have the same API. And I think you just pull the Docker image and you set it up as any other third-party service, open source that you can download and run. Of course, then it gets a bit tricky if you want a particular domain name, but this is more on the infrastructure side with certificates, domain names, and whatever. But I don't think it's particularly hard. If I recall correctly, there is a version of a simple PyPI that you can actually pip install and run as is, and it will work. Of course, depends on your needs. You will choose some one application or another, but it's not super hard. The hard part is more in the infrastructure side of setting everything up and making sure that all the permissions, authentication or whatnot works correctly, rather than the actual instance of PyPI. Yes.
Yeah, I have a kind of practical question. How we can put dependencies if my package supported the versions from Python 3.6 to 3.9?
Mm-hmm. In the same way that you can specify bigger or equal than, you can specify the other way around. So you can put, I don't know the exact syntax right now, but you can put some sort of bigger than 3.6 and smaller than 3.9. Sorry?
Like between versions? Or
No. You just need to put bigger than 3.6 and smaller than 3.10, for example, or.
ethical questions, like if I know there's some libraries that my package supported, some libraries, should I put also like between two versions of library, or I should put better, I should put the strict version?
I would recommend to always leave it as open as possible, because it avoids possible conflicts. And if you know, for example, that you're going to use, I don't know if it's the case, but if you know your package will use pandas, and you know pandas doesn't work with Python 3.11, in my package that use pandas, I would not put anything there, because pandas will take care, the metadata for pandas will take care of that. But for example, if at some point pandas is available in 3.11, then you don't have to change it, because pandas will take care of that. That's my recommendation, because then you don't have to keep track of your version dependencies versions, and you can just leave it as is. Of course, if you notice something with a particular version of pandas, let's say, you can always ban it from installing at the same time. But in general, I would say leave it as open as possible within the boundaries of your application or your code, and it's way less headaches. Yes?
Well, thanks for the talk. I would like to know, well, it's a question.
Yeah.
It's fine if you want to bundle Python files, but actually if you want to add other kind of files, binary files, for example, what's your experience on that, or any recommendations?
Yes, that gets a little bit tricky, because of course you have to interface at the install time. So if you want to install, for example, binaries written in Rust, for example, of course you have to download them at install time. And I'm not sure how to do it with the new PyProject.toml. I know it's certainly possible. And I don't know if you remember, but in the build side of things, you specified a class that will be used to build your package. And I think you can somehow override this class to make sure that to download your binary in this case. I know there are some Python packages that actually do this. For example, an example that comes to mind is shellcheck, which is a linter for shell scripts. And there is a package, PyPI package, which does exactly that. You install PyShellcheck or ShellcheckPy, and it will install in your virtual environment the binary for shellcheck without you having to install it in your system. It's certainly possible. I have never done it myself, but it is possible, and I'm sure that with a bit of research you could as easily as this can be to do this. Of course, with the older version on setup.py, you can do it there directly, because it's the script that is run when pip installs your package. So that maybe it's a bit easier, but yeah, it's certainly possible. Yeah.
Thank you.
Yes.
Is there any naming convention?
Strictly speaking, no. You can use whatever, but of course, we have our wonderful PyPI that tells us how to name things in general, and I would strongly recommend to follow PyPI for naming anything. Of course, for example, one rule I follow is I prefer dashes for the Python package itself. So for example, Django Simple Analytics would be dash separated, but for the actual module that you import in your application, it would of course be underscores, because it's not allowed as a Python variable name. So that's my take. Someone else might disagree, but it is what it is. Yes.
One thing I liked about the talk is that so one can think of other third-party sort of repositories, other packaging tools. Anaconda comes to mind, for data-related people. But what I really like about this talk is that it is really vanilla, in the sense that most of the tools that you have described are sort of standard library or kind of official. So what is the degree of officiality? So what is the difference? Like what is owned by Python as in standard library? What is like third-party modules but owned by?
So everything that I showed you today is officially supported. So for example, as I mentioned, the build package and the Twine are, I think they started, at least Twine, they started with as a third-party dependencies for making developers' life easier, but they got absorbed into the Python Packaging Authority. So they are officially Python maintained and funded by the Python Software Foundation, and with the build tool as well is in the same part of the Python chain. And everything I've talked today, I think it's standard library or very close to it. So everything you can find, everything I've talked today on the official Python docs. So nothing of the sort here. Of course, there are other tools that you can use to package your application. But if you're starting, I would recommend to stick to this, because it's officially supported. You know it will work, and if you then, once you have tried it for a few times, how it works and want to check what these other tools have to offer, of course, please go ahead. But of course, it will not be Python supported. And then, for example, for a newer version of Python, it might take a while to catch up, because of course, everyone who works, or almost everyone who works on open source is not paid to work on this, so you have to respect people's times and time to catch up with the new versions. Cool. Yes?
One more question, please.
Yes.
Do you know any package or library that you can use to add the git, shard, omit in the bundle, I mean in the wheel?
Yes.
Because when you are coding in development mode, sometimes you are building some packages, and given that the Py project file only specifies the version, I haven't found it, I mean, maybe it's me, but I haven't found a broad open version of that.
So pip allows you to install packages directly from Git. So you can specify, there's a way, there's a specific syntax, and I believe you can use this same syntax in your dependencies, either optional or otherwise. And so you can definitely do that. Of course,
But for building the package?
It will be the same. So at build time, the build tools do not download any dependencies. They will only be downloaded at install time. So at install time, pip will look for these dependencies in particular. If the syntax is correct, it will pip install your Git hashed URL directly.
It's not a better practice to tag the version?
Yeah, no, but sometimes when you are in localhost and you are building, sometimes and you build a couple of times and you have several commits, maybe before you go to the merge and you have several packages installed on your system, do you want to know which one is the right one that is working? So sometimes when I'm on my local host, they have some issues to see, okay, that's the last one, or this package is related with this.
Oh, okay. You mean the package version, like your own package version? Okay.
I'm not talking about the dependencies. So
Okay.
dependencies from Git. I was talking more about in the package name.
Okay.
Introducing the
So you remember when we installed our own like the package itself in our environment, we used pip install -e. This -e ensures that our code or the code that we are importing, like our code which is imported by, for example, our tests, is updated at the same time that we update our code. So I don't know.
But introducing that information in the
I mean, as I mentioned, the version of the package is just a string, so you can use any kind of whatever string you like. Of course, then it will mean that your users will have different troubles in installing your package if your version schema is very weird. But you can put whatever you want in there. I would not recommend putting Git shas in there because, of course, this is something that's already supported by pip, and if you don't want to version your package at all whatsoever for whatever reason, if you not upload it, for example, to PyPI, I would leave this as a 000, for example, or 100 or whatever, or fixed or whatever thing floats your boat. But then you can tell your users to install it directly from Git, and you can use a reference to, for example, the main branch. And then every time you install that application with that dependency in that way, it always pull the latest version available in GitHub, for example.
I was thinking because I'm coming from GVM world,
Mm-hmm.
and I know that when you're coding on local, you have
I see.
suffix snapshot,
Mm-hmm.
and with some more metadata information. So
Yeah, I don't think it matters in this case because Python, you don't have to compile Python, and so.
There are a couple of tools like that are very strict about pinning the dependencies, like PyPI, Poetry. In there, you will have log files with the specific commits of what has been installed.
Yeah, and hashes as well.
The exact hashes and the exact information to replicate the environment. And then I think that if you pip freeze, if you run pip freeze, then it will export the exact dependencies that you have installed in the environment as well.
Yes.
And I don't know if the commit will appear there.
You can use, so yeah, very, very interesting question. Of course, as Alberto said, you can, tools like Poetry, for example, will create what is called a log file, which will tell exactly what specific version you want to install. And of course, you can do this without Poetry. Of course, we were talking about library code mostly, so you don't want to pin to a specific version, but of course, in your application, you would want that. And what I would do is to define my dependencies like that and use a tool called pip tools, which will compile your dependencies into a requirements file. And you can, for example, add hashes in there, which will contain information about the actual commit, well, not the commit directly, but the state of the code. And so you, pip at install time will check this hash against the hash that it has stored in PyPI and ensure that you install this exact same version every time. I don't know if it is answer your question, but if you want, we can talk more about it later.
To check temperature, it was the good time to move into the drinks. Are there any more questions? Okay, so